Here we're going to motivate the solution for linear, autonomous, homogeneous discrete equations. So for example, consider this equation below, that the next iteration value equals 7 times the previous iteration value. And we're also given the initial condition that x at n equals 0 is equal to 3. So last week in class, we discussed that we would try solutions of the form xn is equal to some number, lambda, raised to the nth power. And what our job was trying to figure out what is lambda. If we're able to find a value of lambda, we would effectively have the solution to our problem. But what we didn't really dive into in class was, why do we guess solutions like this? So this video is just going to motivate why we're guessing solutions of xn equals lambda to the n, or where this solution ansatz comes from. So the first thing I'd like us to do is just try iterating. And again, we're just motivating where this solution comes from. So if we start off with x0, we're told, hey, that equals 3 right from the start of the problem. Well, if we find the next iteration value, x1, well, we're told that by this recipe, that the next iteration value is equal to 7 times the previous. So x1, in this case, would be equal to 7 times x0, which of course we know what x0 is. That was our friend 3 from the start. Well, let's keep iterating. x2 is now equal 7 times x1, which we know what x1 is. x1 we previously found to be 7 times 3. And in fact, let's not multiply that out, but let's write that again here. So this is 7 times 3. And we could keep this process going. If we have x3, that's equal to 7 times the previous value, 7 times x2, which in this case was equal to the previous line, 7 times 3, or this is now 7 times 7 times 7 times 3. In other words, the third iteration value is equal to 7 to the third power times that initial value of 3. And what I want to draw our attention to right now is we're on x3 and we see a pattern that we have 7 raised to that third power. Similarly, in the x2 case, we saw something happen like that. Now, we left this as 7 times 3, but we could equivalently write this as 7 squared, all times 3. And again, what we see happens is the second item in that list, or the n equals 2 item, is equal to 7 raised to that same power, 2, times the initial value. And if we kept going, you would see this trend keep going, or this pattern keep going. If we're looking at the nth value, well, we could just keep this iteration process going and see that this would equal 7 to the nth power times that initial value of 3. In other words, we see that nth iteration is equal to some number raised to the nth power times the initial value. So that is where this original solution ansatz comes from. Just by doing iterations and seeing that we're constantly getting numbers raised to the power of n.